Okay, so at a fireworks display, a firework is launched from a height of 2 meters above the ground and reaches a maximum height of 40 meters at a horizontal distance of 10 meters. A, sketch this flight path and label the axes. So what we're going to do right here, first things first, let's label our axes. So one of our axes has to be the height, and the other axis has to be the horizontal distance. So let's read the question one more time. At a fireworks display, a firework is launched from a height of 2 meters above the ground and reaches a maximum height of 40 meters at a horizontal distance of 10 meters. So we know that one variable represents the height, so our y is our height, and our other variable represents the horizontal distance. So let's just label these axes. So we have our horizontal distance. No, we won't label it in highlighter. We have our horizontal distance. And this, let's see if I can write it sideways. This is our height. I think I write neater sideways. And y is our height. Okay, so let's just make a very rough sketch of this parabola so we can see what's happening. So it's fired from about 2 meters above the ground. It continues up. It reaches a maximum height of 40 at 10 kilometers, and then it starts coming down. So this maximum here is 40 in height, and that occurs at 10 at a horizontal distance of 10. Okay, so that vertex, based on that information, is at 10, 40. So that's good. We've determined our vertex, and we know that's a very key piece of information when we're going to be able to write the equation. Okay. So part B is determine the equation to represent this flight. We know when we're writing the equation of a parabola, we need the vertex, which we have, and also another point on this parabola. So let's look at the question and see if it tells us a piece of information about another point. And if we look, it says that a fireworks display, a firework is launched from a height of 2 meters above the ground. So basically what that's saying is that at a horizontal distance of 0, it's launched from 2 meters high. So it's telling us that the y value right here is 2. So that point is at 0 on the x-axis and 2 on the y-axis. So we now have 2 points. We have the vertex and another point on the parabola. We remember that these stand for h, k, and x, y. So we can write the equation of the parabola based on this information. So let's go ahead and do that. So what is the vertex? The vertex we discovered was 1040. So I'll just jot that down. Vertex 1040. Another point on the parabola, which in this case was the y-intercept. It crosses the y-axis at 0, 2. So our another point was 0, 2. Plug all of this information into the vertex form. So sorry, this is our h, this is our k, this is our x, y. Plug all of that in to this equation, and we get 2 is equal to a, x is 0, minus 10 is h, plus 40 is our k value. Okay, if we go through and simplify this, we get 2 is equal to a, negative 10 squared plus 40. 2 equals a, negative 10 squared is 100. So a times 100 is 100a, so I'm just going to write it in that form. 100 A plus 40. Move the 4 to the other side, subtract it from the 2. So I have 2 minus 40 equals 100A. Negative 38 equals 100A. Let's move our page down even further. Divide both sides by 100 so that we can get A by itself. Good. So these 100s cancel. And we can write this fraction in lower terms. Negative 38 over 100, let's write that as negative 16 over 50. So negative 16 over 50 is equal to A. And if I'm not mistaken, that's in lowest terms. So we've solved for our A variable. And we remember when we write the equation of a parabola, we then we plug in our values for A, H, and K. And we don't plug in anything for X and Y. So the equation of this parabola is Y equals negative 16 over 50 x minus 10 squared plus 40. Because our A is negative 16 over 50, our H is 10, our K is 40. That's our final answer right there. Good. Okay, now we want to do part C. The firework continues to travel an additional 1 meter horizontally after it reaches its maximum height before it explodes. What is the height when it explodes? So what this question is saying is, what is the height after it's traveled an additional 1 meter horizontally after it reaches its maximum height? So 1 meter to the right of the vertex, what is the height of the firework? I'll say that one more time. So the question says the firework continues to travel an additional 1 meter horizontally after it reaches its maximum height. So what the question is saying, 1 meter to the right of the vertex, what is the height? Okay, so let's figure out what is the x value 1 meter to the right of the vertex. Well, the x value of the vertex is at 10. Okay, so x equals 10. The x coordinate of the vertex is 10. 1 meter to the right, we have to add 1. So it will equal 11. Okay, so the question is asking us, what is the height? So what is y when x is 11? So let's remember our equation was y equals negative 16 over 50 x minus 10 squared plus 40. So if we plug in x equals 11, we plug in 11 for x. If we go through and solve this, we get y equals negative 16 over 50. 11 minus 10 is just 1. And 1 squared is just 1. So 1 squared is just 1. And when we multiply anything by 1, it just stays the same. So that's gone. And we're still left with the plus 40. So if we convert this to a decimal and solve, so we don't have a huge fraction, we get y equals 39.68 meters. So you'd write a nice sentence. So the firework is 39.68 meters above the ground when it explodes. Make sure we relate our final answer back to what the question is asking us. It says, what is the height when it explodes? The firework is 39.68 meters above the ground when it explodes. Good. Okay, I'm going to put up one more question for you guys to try. I'm not going to go through the solutions, but what I'll do is just put the answers there so you can make sure you're able to get the answers. Okay? So the question is, if I was shot out of a cannon, my flight is represented by this equation. H is the height above the ground, and T is the time. Okay? So what you want, let me just get you started by showing you the graph here. So let's just extend the page. Okay, so I'll just label our axes for you. So I've told you that T is our time and H is our height. So good. So if I want to be able to sketch a graph of my flight, let's just sketch a rough graph. I know my vertex is HK. So I'm going to be shot out of a cannon. I'm going to go up, and I assume I'm going to come back down unless I somehow get powers to fly. Gravity will still work on me, and I'll unfortunately come back down to the ground. Hopefully I don't get hurt. Anyway, so my vertex, based on my equation, is 6 and 182. The rest of this question, you're going to be interpreting this vertex, okay? So you're going to find the maximum height. You can find it from the values of the vertex in here. How long does it take me to reach my maximum height? You can tell that from the information given there as well. And how high above the ground was I when I was launched out of the cannon? So when I was launched, time was 0. Okay, so you'll have to go through it when time is 0. What's the height? So I'm just going to go through and fill out the answers quickly for you here, so we can you can give this a shot and make sure you're able to get those answers. So part B was find the maximum height. So the maximum height should be 182 meters. C, how long does it take me to reach my maximum height? 6 seconds. D, when time is equal to 0, when T equals 0, that's when I'm launched. When T equals 0, the height is 5.6. Okay. So make sure you can go through and figure all those out. You're able to interpret the vertex. Okay, this vertex, the x-coordinate represents the time. So at 6 seconds, my height is 182. The y-coordinate is 182. So at 6 seconds, that's my maximum height of 182 meters. And then once again, how high above the ground when I was launched. So when time is 0, plug in 0 for t, and we would solve that our h value is 5.6. So the homework from this lesson is out of Principles of Mathematics 10, do page 185, numbers 6, 7, 13, and 14. Okay, good luck. Thanks for listening. If you have any questions, please post a comment or ask me in class. Okay, thanks. See you guys.